All right, here we go. So what we're doing now is solving quadratic equations. That's what we've been doing. Yesterday we introduced you to the zero product property. And so today we're going to talk about another way that we can solve a quadratic equation. This is actually one that we've done before, and that is using a graph to solve a quadratic equation. So what does that mean? Well, if I take a graph, if I want to sketch this graph, well, how can I sketch a graph? Well, lots of different ways. We can do different things. One of the things we talked about when we had this was negative b over 2a. So if I look at this problem right here, I would call this b, and there's no c, c would be 0, so that would be negative 2 over 2 times 1, because that's a, that's b. All right, c is not there, it's 0. 2 over 2 is 1, so that would be my axis of symmetry. All right. And then I take 1, plug it back in, all right, to find my vertex, plug in 1. 1 squared minus 2 times 1, that's 1 minus 2 is negative 1. So my vertex is right there. Okay. The axis of symmetry you plugged in and the answer you got out when you plugged it in. This should all be coming back to you. And then I can just sketch my graph. I know there's no stretch here, so I can use my same relations. To sketch the graph. All right. So what does this mean to solve? Well, when we did our zero product property, we talked about when the equation is equal to 0. So remember, the value of the equation is the y-axis. Okay. If I plug in, I would get the calculator out, and I would plug in 3. Then I would get 3. If I would plug in negative 1, I would get positive 3. If I would plug in 4, I would get 7. The y value is the value of your function at a certain x. So where is this function equal to 0? Well, right here and right here. That's where it's equal to 0. So at 2, it's 0, and at 0, it's 0. These 2 points, at 2 and at 0, it equals 0. So those are the x-intercepts of the graph, where the function equals 0, where the y equals 0. So this particular function has 2 x-intercepts. This is why I told you yesterday the exponent tells you how many answers you have, because the x squared hits that. A lot of our parabolas hit twice. So the solutions to this equation is what x values make y equal to 0. Well, I can look at the graph and I can see 2 and 0 make x equal 0. So my answer here would be 2 and 0. So I can use the graph, see where it crosses, and those are my 2 answers. All right, that's how we use a graph. All right, so for this to work, I got to have everything on the same side. We talked about this yesterday because it's got to be equal to 0 for this to work. So this is the graph the related function. So basically, pretend that 0 is a y, graph what you have, find the x-intercepts. All right, so if I wanted to graph this, first I have to get it equal to 0. All right, and then I graph. Well, I can graph, and we talked about a lot of different ways that we can graph. We can graph by what we just talked about, negative b over 2a. So that would be negative 2 over 2 times 1. So that comes out to be negative 1. So if I'm sketching this graph, negative 1 is my axis of symmetry. I plug negative 1 back in. I do that, yeah. So when I plugged in negative 1, I got negative 4. That becomes So the number I plugged in, and this becomes my vertex, and then I sketch the graph. I know there's no stretch, so I'm gonna go 1, 1, and you thought we'd never used this before. Then I would go 2, 4, and I can look at the graph and I can see the positive 1 and negative 3. That's where my graph hits the x-axis. So those are my solutions. So this is one method. I'm going to show you another method that you might like a little bit better. Any questions on this method before we continue? All right. So an alternative method is to factor. Do you know anything that multiplies to negative 3 and adds to positive 2? Multiply to negative 3, add to positive 2, and of course 3 and negative 1. Do that. So now I know this factors to x plus 3, x minus 1. So now I can use my zero product property from yesterday, and I know that x is negative 3 and 1. Same answers. Oh, Mr. Stevens, that's so much better. Yeah, I agree. If something can factor, this is a much faster, quicker, cleaner, easier way, which is why we talked about the zero product property yesterday. However, not everything can factor, okay? So keep this in mind. You always want to try this method first. If this method fails, if you can't find a factor, then go to negative b over 2a. But we always want to do this first because it is much, much better. All right, so if I ask you to check the equation by graphing, let's do number 2 together. So the first step, I have to get it equal to 0. Second step, I want to factor. So, do you know anything that multiplies to 10 and adds to 7? Sure. There you go. So what are the zeros? Set this equal to 0, I get negative 2. Set that equal to 0, I get negative 5. Okay? There you go. Do number 3 on your own. Remember, I have to get it equal to 0 first. Now, what multiplies to negative 12 and adds to positive 6? That would be positive 4 and negative 3. So remember, you do the factoring part first. Don't get ahead of yourself. Don't try to do a ton of this stuff in your head. Write these steps down. Set this equal to 0, I get negative 4. Set this equal to 0, I get positive 3. All right. Question, comments, or issues on that? Moving on. Same thing. So if I have a problem like this, notice the negative x squared here. I can't really factor with the negative x. I mean, you can, but it's just a mess. There's things you have to do. So I need my x squared term to be positive. So instead of putting these two terms to the left, instead, I'm going to add x squared over here. All I said is it has to be equal to 0. I didn't say it had to be on the right or the left. Now I have the equation set equal to 0, and I can continue like I've been doing. What multiplies 4x? So this is x plus 2, x plus 2, so that x is negative 2. There you go. There you have it. Of course, this one's going to come out to be the same thing twice. I touched on those the other day. If I would graph this, it's just when the parabola touches there one time. All right, so not everything has 2 answers. Well, it technically has 2 answers. It's just the same answer twice. Okay? All right. Any questions about any of that? Cool. Let's practice this. Do number 9 on your own. Okay, I'm going to write up here. So again, I need the positive x squared. I'm going to put this over to this side, so I get x squared. And again, do you know anything that multiplies to 5 and adds to 2? And of course there is not. So I need to go back to the other method. That's just how it goes. Negative b over 2a. Negative 2 over 2a equals negative 1. So then I plug in negative 1. Negative 1 squared plus 2 times negative 1 plus 5. 1 minus 2 plus 5 is 4. So I have negative 1 comma 4 is my vertex. My graph. There's my graph. Where does that hit the x-axis? Yeah, it doesn't hit the x-axis, does it? Okay, so what do you think the answer is? There you go. If I have a graph that goes up and the vertex is above the x-axis, it's not going to hit. Now, I'll put a caveat here. The answer is no real solutions. And we're going to talk about that next week, about what that really means, because there's something called an imaginary solution. We'll get into that a little deeper next week. All right? So, graph, if you can't factor, then you go to negative b over 2a, plug it in, find your vertex, sketch a graph, and see where it crosses. Cool. Next. So sometimes I'll just give you a graph. What are the zeros? What are the x-intercepts of this function? Well, look at the graph and tell me. So obviously I can see right here, it crosses at negative 1, positive 2, positive 3. So there you go. By looking at the graph, I can see what the functions are, what the zeros of the function are. Excuse me. All right. And then lastly, it won't always hit at whole number locations. So you need to be able to estimate. So it says here, I want you to tell me the nearest tenth where the zeros are. So I look here, I would say this is negative 3.8. Where do you think this one is? Yeah, so here's 0, here's 1. I'm going negative 0.2. I don't know. So estimate to the nearest tenth. A couple of those on your homework. All right, that's it. That's using the graph. We either factor and use the graph that way, or we use negative b over 2a if it doesn't factor. All right. Good luck. Get to work.